All right, guys, let's talk about exponential and logarithmic equations. All right. So essentially, the rest of this chapter, we're basically showing different equations and how you would go about attacking those equations. So with these equations here, there's a couple of things that we kind of want to look at it. So for example, so I'm basically doing just examples here. So here we go. Let's use example 1 here. So what we can, so if we're given 5 raised to the 3x minus 6 is equal to 125, okay? So my first goal is to see if I can not create, but I guess, can I make both sides have the same base? In other words, the thought process is this. If I have 2 to the x is equal to 2 cubed, right? And since the bases are the same, let me do this here. Whoa. Come on. Okay. That's exactly what I wanted. Okay, so since the bases are the same, then I can say that the power has to be same as well. Okay, so that's what I want to try to do. So that's my first choice. So the question is, can I make 125 a base of 5? So 5 raised to what power would give me 125? So let's take a look here. So if I have 5 raised to the 3x minus 6, that's going to equal to 5 raised to what power? Well, 5 times 5 is 25, times 5 again is 125, so it would be 5 cubed. So since the bases are the same, I can say that 3x minus 6 is equal to 3. Now I just solve from there. Add the 6 over. I have 3x equals 9. Divided by 3, so x is equal to 3. And there would be my answer. Okay? Not too shabby, right? So again, our first choice is to see if we can create or make both sides have the same base. If we can have the same base, then it's easy. We just take their powers or the exponents and set it equal to each other. All right? What's a second possible equation that we can have? So example 2. What if we're given something like 5 to the x is equal to 134? Well, with this case, because again, I'm trying to have it the same base on both sides. Well, this is a base of 5 on the left side. On the right side, I can't have a base of 5 to get 134 because 5 to the first is 5, 5 squared is 25, and 5 cubed is 125, and 5 to the fourth is 625. So that doesn't work. So let me write that over here to the side for you guys. So I know 5 to the first is equal to 5. 5 squared is 25. 5 cubed is 125. And 5 to the fourth is equal to 625. So if you notice that 134 is nowhere in there at all. So therefore, I can't make this the same base. Now, if 5 was a different number and I can create that to a different base as well, then I can do that as well. So, so if I can make both sides the same base, so if the left side was a 25, if that was a 25x, I could make that, here, let me write it down over here. So if the left side was to be, let's say, 25x, actually, let me do a different color here so that you're not confusing the two. So if the left side was to be, let's say, 25x, I could change this to a 5 squared raised to the x. And if you remember, if I raise the power to a power, I multiply the power, so this would be 5 raised to the 2x, okay? If that was the case. So I could convert both the left and right side to have the same base if I could do that. But since 5 is already a prime, I can't really break that down anymore. All right. So from here, if I can't do that, then what I want to do is, I think the easiest method to do is using the natural log. So I'm going to take the natural log of the left side, and I want to take the natural log on the right side. So if I do it to the left side, I have to do it on the right side. Just the same thing as if it was squaring on one side, you have to square the other. If you take the square root on the left side, you got to take the square root of the other as well. All right. But over here, what you did learn here is the power rule. Okay. And the power rule tells me that the power would come down, leave me the ln of 5, and that would equal to the natural log of 134. All right, so, and this is a product here, so it's actually multiplication. So what I can do is divide both sides by the ln of 5. So my x is actually equal to the natural log of 134 divided by the natural log of 5, and that is going to be, I can't say equal, it's going to be approximately 3.04. Okay, and my last plus will tell you where to round that number to. So again, first method, try to get the bases on both sides the same. If you can't do that, then take the natural log of both sides. Okay. And what's the third method? Well, the third is going to be pretty obvious, I think. I think if you see this, you'll be like, oh, I just got to convert it. So if I said the log base 2 of x minus 4 is equal to 3. All right. So the thing that you guys did remember back a little ways, back a little ways, this is a lot further than you would want it to be. Remember that we were able to go from x is equal to b raised to the y, all right, and convert that to y is equal to log base b of x, okay? So if you look at this, here's my y, here's the equal, here's the log, base b, and this is my so-called x here, okay? So if that's the case, so let's go ahead and convert this appropriately. So the x is equal to, so I got x minus 4 is equal to b, which is 2, raised to the y, which is 3. Okay, so let me move this down. All right, so what I was doing is moving the appropriate pieces here because I said x is equal to b raised to the y. Okay, so let me rewrite this here because some of you guys might think that looks like a 6. So there's my b raised to the y. So essentially I'm just taking what I have and reordering it so that I have the exponential function equation rather than a logarithmic equation. Okay, so from there I just simplify and solve. So I got x minus 4 is equal to 2 raised to the third power. 2 raised to the third power is 2 times 2 times 2, which is 8. Add 4 to both sides, so x is equal to 12. Right? Not too shabby. So there's one more that I kind of want to do with you guys that you're probably going to see more than these 3 here because these 3 overall are pretty simple. Okay, so let's do one more that becomes a little more complicated, and you guys usually like me to show that anyway. So let's do example 4. All right, so let's say we're given this. 3 raised to the 2x minus 1 is equal to 7 raised to the x minus 1. Okay, so if you notice here, I have a base of 3 and a base of 7. I definitely, since the 3 is a prime and the 7 is a prime, I can't convert those to any other bases to make it the same base. So therefore, I'm either going to use the natural log, or I can use just log base 10. So I'm going to actually use the regular log. So I'm going to take the log of both sides. So 3 to the 2x minus 1 is equal to the log of 7 raised to the x minus 1. Okay, so I'm going to apply the power rule. All right, so what happens? I'm going to have 2x minus 1 times the log of 3 is equal to x minus 1 times the log of 7. Okay? And then over here, what I'm actually going to do is I'm going to distribute. Okay, so then I'm going to distribute. Not the order that I'm used to, but essentially I'm doing this. Kind of backwards of what we're used to here. So I'm going to have a 2x log of 3 minus just log of 3 is equal to x times the log of 7 minus log of 7. Okay, actually, you know what? Let me put some arrows here so that you can see I'm kind of like distributing backwards here. All right. Okay. So again, my goal when I'm solving, I'm trying to get x by itself. So what I'm now going to do is this. I'm going to show you, basically I want to get all the x's on one side and all the numbers to the other. And log of 3 is just a number. Log of 7 is just a number. All right. And if you notice, I'll use underlines here. So this right here and this right here both have x's, all right? While, I'll use a different color here, this here and this here, log of 3 and log of 7 are just numbers. So I'm going to try to bring all of that to one side. I want to bring it to the right side, all right? So I'm going to add the log of 3. Okay, so I want to bring that to the right side while I'm trying to get the x's to the left side. So I'm going to subtract this x log 7. So I got to subtract x log 7. Okay, so what do I have after this? So what I'm going to have is the 2x log 3 minus x log 7. Okay. This goes away, and this goes away. All right. So what do I have left on the right side? I have is equal to log 3 minus log 7. Are we okay with that? Okay. So now, if you look on the left side, I have a GCF. I can factor out an x. If I factor out an x, what do I have left? I have a 2 log 3 minus log 7. All right. And the right side is still log 3 minus log 7. Now notice I haven't said anything about the base because I'm actually using the log base 10. And with the log base 10, I don't actually have to say log base 10. When I say log 3, it's understood as log base 10 of 3. All right. So from here, I can get x by itself, right? If I divided it by the 2 log 3 minus log 7. So if I do it to the left, I must do it to the right. Okay, so what's my x? Well, that's going to be log 3 minus log 7 all over 2 log 3 minus log 7. And that, ladies and gentlemen, would be your answer. Now, you can put this in your calculator and actually get a numerical value or approximate numerical value for it. But this problem right here, you might have to go back over it a couple of times, even on the video, which is fine. I think it's a good idea to kind of say, okay, what did I miss? Because I'm sure that by the time you get about halfway, it's a little overwhelming, okay? And you're gonna be like, well, how am I gonna see this? So one thing I'm gonna say is if you can't get the base by itself, to be the same, kind of like example 1 here, where I can get the base to be the same. But example 2 says, well, if I can't get the base to be the same, I'm either going to use natural log or I'm going to use the log base 10. I think those are the 2 easiest way of solving equations. So if I can't get the bases to be the same, I'm going to use the natural log or the log base 10. And once I do that, chances are the power rule is going to have to come into play. So then your question is, well, how did I know to distribute? Well, to know to distribute is because you needed to get the x out of those parentheses. In order for you to get the x out of those parentheses, you had to distribute so that you had an x value and just a plain old number, which is the log of 3. So once you get that, what's my next step? Well, this is kind of like if it was polynomials, right? You're just trying to get the x's to one side and the numbers to the other and get x by itself. So that's the reason why I moved those two so that the x's is all on the left side, the numbers all just to the right, and then from there is how I solve for x. So again, you might want to revisit this part of the video several times to kind of help out a little bit. If you have any questions, you know how to get a hold of me.